Chapter 11 Artificial Intelligence Learning Objectives Machine Learning Deep Learning Reinforcement Learning Recommender System Introduction Artificial intelligence is the science and engineering of creating intelligent machines. These machines have an ability to perform activities such as speech recognition, problem solving, decision making, perception, learning, and planning. Machine learning. Machine learning is a subset of artificial intelligence which facilitates software applications to become more accurate in predicting the future decisions on the basis of their past experiences without being explicitly programmed. It uses the previous and historical data as its input and predict new output values. Today, various leading companies such as Facebook, Uber, Google, etc. are using machine learning as a central part of their operations. This technology is used to train machines to perform various types of tasks like predictions, recommendations, estimations, etc. The three main key aspects of machine learning are task. Task is defined as a problem which must be related to the predictions, recommendations, and estimations, etc. Experience. Experience means to learn from past data and uses it to solve future tasks. Performance. Performance is the capacity of a machine to resolve a problem and provide the best possible solution for it. How machines get trained. Machines are given some trial data to access. As the machines go through these trial data, they learn themselves. These machines are not specifically programmed to perform such tasks and therefore eliminating the requirement of writing millions of lines of written code. They learn and improve from their experience automatically. Types of machine learning. Machine learning can be categorized into three types: supervised learning, unsupervised learning, and reinforcement learning. Data, machine learning, learns, predicts, improves. Supervised learning. Supervised learning is applicable when a machine has sample data. Here sample data is the input and output data with correct labels. Correct labels are required to determine the correctness of the model. In this type of machine learning, the output is already known and the algorithm is corrected each time to optimize its result. This type of learning occurs when a machine is fed with the data to learn from and the guidelines for what output is expected. It also predicts the errors during the entire learning process and also corrects those errors through algorithms. For example, suppose we have a set of images tagged as car. A machine learning algorithm is trained with these images so that it can easily distinguish whether an image is a car or not. Machine learning. Input, feature extraction, classification, car, not car, output. Unsupervised learning. Unsupervised machine learning is another type of machine learning where output is unknown and only input variables are available. There is no labeled information as it is in the case of supervised learning. The machine figures out the output and predictions on its own. Therefore, the output it produces may not be always correct. Reinforcement learning. Reinforcement learning is a feedback-based learning method. In this type of machine learning, a learning agent gets a reward for each right action it performs and also gets a penalty for each wrong action it performs. A machine can make a series of decisions based on rewards, punishment, or feedback it receives for its actions. The machine learns automatically with these feedbacks and improves its performance. The main goal of a machine is to get the most reward points and improves its performance. Some real-world examples of machine learning. Music or video recommendations. Various e-commerce websites like Amazon, Myntra, or Flipkart use the recommendation systems which recommend you more products when you start searching products in those sites. These systems observe the online searching habits of the user and the previous searches he has made and learning these observations. On the basis of the data they have learned and collected, they make the further recommendations to the user. Image recognition. Image recognition is another example of machine learning which can identify an object as a real image on the basis of the intensity of pixels in black and white images or colored images. Machine learning is also used for facial recognition, where it uses the database of people and search the database to find the correct match. Various social media sites are using image or face recognition systems to give you tag suggestions. Speech recognition. Machine learning is also used to translate speech into text. There are various speech recognition systems which can convert the live voice and recorded speech into text. One most commonly used speech recognition system is in voice search. Today, almost all the computing devices has voice search system which enables users to search for anything by speaking to the device like Alexa by Amazon or Google Assistant by Google. Deep learning. Deep learning is a subset of machine learning. Machine learning enables a machine to learn from the data using algorithms to perform a task without being explicitly programmed, whereas deep learning enables a machine to learn to think by using the complex structure of algorithms modeled on human brain. It is essentially a neural network with 3 or more layers. Using these neural networks, a machine is able to simulate the behavior of human brain and is able to learn from large amount of data. To provide impressive results, deep learning requires large amount of labeled data and substantial computing power. Relation between deep learning and neural network. Deep learning is based on artificial neural networks. Neural network is a network of neurons that make up human brain which can interpret the context of real-world situations. Artificial neural networks have millions of artificial neurons which are called nodes or units. Artificial neural network. Neural network of human brain. The concept of deep learning was introduced in 1943 when Walter Pitts and Warren McCulloch created a computer model based on the neural network of human brain. In artificial neural network, the nodes are arranged in a series of layers. Input nodes. The input nodes receive the data and information from outside world. Hidden nodes. The information received then goes through hidden nodes. Output nodes. The information is transformed into something useful which is used by output nodes. Fact file. The concept of deep learning was introduced in 1943 when Walter Pitts and Warren McCulloch created a computer model based on the neural network of human brain. In the above figure, the nodes in an input layer receive an image of a person. This information goes through hidden layers which are useful artificial neurons to identify the image of a person by going through step-by-step procedure like first, identify the pixel values, edges, combination of edges, then identify the features by combining the edges, then these features are combined to generate an image which is then identified as a picture of a person George. Some real-life examples of deep learning are driverless cars. Driverless cars, also known as automated cars, which can run on the road without human intervention. These cars are able to identify the traffic signals and recognize the stop sign or distinguish between a pedestrian and lamppost. Aerospace and defense. Deep learning is also used in the field of aerospace and defense to identify objects from satellites, to locate areas of interest and identify safe or unsafe zones for troops. Medical research. Deep learning is used in medical research where it is able to detect cancer cells. Teams at UCLA, University of California, Los Angeles, has built an advanced microscope which makes use of high-dimensional data sets to train a deep learning programs which can identify cancer cells more. Relationship between artificial intelligence, machine learning, and deep learning. To know about the relationship between artificial intelligence, machine learning, and deep learning, have a look at the given figure. Here you can see that artificial intelligence is an umbrella term which covers the concept of machine learning. Deep learning is a subset of machine learning. In brief, artificial intelligence is used to develop the machines which can perform intelligent tasks just like humans. Machine learning is making the machine learn from its past experiences. Deep learning is using the complex algorithms and mathematical calculations with artificial neural networks to perform the task. Reinforcement learning. Reinforcement learning is a type of machine learning which is based on the science of decision making. A machine is trained in such a way that it can learn the optimal environment and performs the action to obtain maximum rewards. In this type of learning, a learning agent explores an unknown environment to achieve the goal. For this, performs certain actions to derive maximum rewards. It decides what to do on its own to perform the given task on the basis of its experience. The main elements of reinforcement learning are the learning agent, the environment with which the agent interacts, the policy which is followed by an agent to take actions, the reward that agent gets on achieving a goal. Let us understand it with the help of an example. We have an agent named Robo and a diamond as a reward. The task is that Robo has to reach to the reward, that is a diamond, by avoiding any hurdles in between. For choosing the correct step towards the reward, Robo will get 1 point as a reward. But on choosing an incorrect step, Robo will lose 1 point from its reward. When it reaches to the final reward, that is diamond, calculate the total number of rewards it has achieved. The main points in reinforcement learning will be input. The input is the starting state from where the model will begin. Robo, obstacles, final reward. Output. The output can be many because there can be many solutions of a particular problem. Training. The training of the model is based upon the input. The model will return a state and the user will decide whether to give a reward to the model on its actions or to punish it. Learning. The model keeps on learning and stores the data as its past experience. Best solution. The best solution to the given problem is decided on the basis of the maximum rewards received by the model. Let us take another example. Look at the below figure. Here, a vacuum is an agent whose task is to move from one block to another. If there is a dirt in a block, clean it thoroughly. If there is no dirt, then move to next block to check and clean it. Here we have total 9 blocks. The vacuum perceives which block it is in and whether there is a dirt in it or not. It can decide to move left, right, up or down and suck up the dirt. A small positive reward is given to the vacuum when it explores, finds and cleans the dirt from a block. A small negative reward is given to it if it tries to clean an already clean block, and a big positive reward is given to it when all the squares are cleaned. So, an agent is able to learn that what actions lead to positive feedbacks or rewards and what actions lead to the negative feedback or penalty. As a positive reward, an agent gets a positive point, and as a penalty, it gets a negative point. Key features of reinforcement learning are: the agent is not instructed about the environment and what actions need to be taken by it to reach the desired goal. This method is totally based on hit and trial process. The agent takes the next action and changes states on the basis of the feedback it is given on its previous action. The environment is stochastic and the agent needs to explore it to reach to the goal to get maximum rewards. Recommender system. Recommender system are the powerful engines which uses machine learning algorithms to segment customers on the basis of their behavioral patterns and user data. The main purpose of the recommender system is to target the customers with personalized products and content suggestions. You may have noticed that when you use YouTube, Amazon, Myntra or Netflix or any other such websites, you get lots of recommendations or suggestions. These suggestions are provided to you by the recommender systems. Types of recommendation systems. There are two types of recommendation systems: content-based filtering and collaborative filtering. Content-based filtering. Content-based filtering is a recommender system in which the relevant items are recommended to the user on the basis of the previously searched items by the users. Here contents refer to the tag of the product that user likes. But how this system works? In this type of system, products are tagged using certain keywords. The system then tries to learn what are the likings of the user. It then explores its database and recommends the products that a user may like. As you can see in the figure, on the basis of the articles read by the user, the recommender system will suggest similar articles to the user that he may like. For example, suppose a user has started to watch movies on Netflix. He is a new user. Therefore, the recommender system has no data and information about the user. Initially, the system will recommend the popular movies to the user. Once the user starts watching the movies and rating the movies, the system will be able to get information about the user, like what type of movies he likes, and on the basis of the ratings or searching habits of a user, the system will suggest more movies to the user. Collaborative filtering. Collaborative filtering is a recommender system in which the new items are recommended to the users on the basis of the interests and preferences of the other similar users. For example, suppose user A has bought two novels, Aristo and Ray Bradbury. User B has bought three novels, Aristo, Ray Bradbury and The Time Machine. The recommender system will get and learn from the similar behavior and likes of two users and recommend The Time Machine to user A. There are two types of collaborative filtering: user-based collaborative filtering, item-based collaborative filtering. User-based collaborative filtering. This type of filtering is based on users' similarity. For example, as you can see in the image that there are three children named as A, B and C on the left side. There are four types of fruits as grapes, strawberry, watermelon and orange. Let us assume that A purchased all four types of fruits. B purchased only strawberry. C purchased strawberry and watermelon. According to the recommender system, A and C are similar kind of users because they both have purchased strawberry and watermelon. Therefore, the system will recommend grapes and oranges to C, which is shown as dotted lines in the image. Item-based collaborative filtering. This type of filtering is based on item similarity. In this type of filtering, the system sees similar items and not similar users. For example, as you can see in the image that there are three children named as A, B and C on the left side. The fruits are given on the right side. Here the system will see that the watermelon is purchased by all the children A, B and C. But the grapes are purchased by only A and B. Therefore, the recommender system will suggest grapes to C. Benefits of recommender system. Increased sales. By setting up an automated recommender system, an organization can benefit with additional sales without any marketing efforts. Increased user satisfaction. Recommender system provides an appropriate option to the customers even before they search for it. They feel satisfied as it reduces their efforts of searching and exploring the entire website. Increased loyalty. When recommender system recommends the things, the customer tries to open and explore those things and spend more time on your website. In this way, you can increase their familiarity with your brand and the interface provided to them. This may help in increasing the probability that they might use your website and purchase the products in future from this site. Engage customers. Recommendation system powered emails are the best ways to engage the customers to your brand. You can offer discount and coupons to your customers with recommendation options to keep them re-engaged. The various companies which use recommender systems are Amazon. It uses item-to-item collaborative recommender system. Netflix. It is a data-driven company which uses recommender system to increase customer satisfaction. Spotify. It uses collaborative filtering recommender system and recommend list of songs to the users. LinkedIn. LinkedIn is also using recommender system to give recommendation to its users like you may also know or you may also like. Quick backup. Artificial intelligence is a science and engineering of creating intelligent machines. Machine learning facilitates software applications to become more accurate in predicting the future decisions on the basis of their past experiences without being explicitly programmed. The machines go through these trial data, they learn themselves. Supervised learning is applicable when a machine has sample data. Reinforcement learning is a feedback-based learning method. Deep learning enables a machine to learn to think by using the complex structure of algorithms modeled on human brain. Driverless cars can run on the road without human intervention. Recommender systems are used to segment customers on the basis of their behavioral patterns and user data. Collaborating filtering is a recommender system in which the new items are recommended to the users on the basis of the interest and preferences of the other similar users. Recommendation system powered emails are used to engage the customers to your brand.